Well, welcome to this online revision session for AQA FP1, in which we will be considering the January 2010 question 9 on conics. Well, the first part of this question gives you the equation of a hyperbola as x squared over a squared minus y squared over b squared equals 1. And we are told that there is a point 20 on the hyperbola, and that the equation of the hyperbola has asymptotes, or the graph does, y equals 2x and y equals minus 2x. So the first part asks us to show that a is 2 and b is 4. Now, to find the equation of the asymptotes, what we would normally do is take the equation that we're given for the hyperbola and consider what happens as x gets larger and larger. So if we rearrange it to make y squared over b squared by itself, we can see we get y squared over b squared equals x squared over a squared minus 1. Now we know that as x gets bigger and bigger, the x squared over a squared will get bigger and bigger, and so the minus 1 becomes less and less significant. So if x is large, we can say that y squared over b squared is approximately equal to x squared over a squared, which if we then rearrange and square root, we can say that y will be equal to plus or minus b over a, lots of x. So b over a corresponds to a value of 2 in the asymptotes that we've been given. Okay. So that gives us the ratio of a and b. Now the other key thing we were given is the fact that the point 20 is a point on the curve. So we're going to need that in order to find one of these two values of b and a. So if we substitute 20 into our equation, we're going to get 4 over a squared minus 0 over b squared, that's the value of y substituted, equals 1. So in other words, 4 over a squared is equal to 1. So a squared is equal to 4. So a is our plus or minus 2 value, as the case may be, which gives us our two possible answers. But the fact that a is squared, we don't need to worry about that. So in fact we don't need the negative value in here. We can just go straight for a as being 2. And if we then substitute that value of a in to the b over a equals 2, that tells us that b is 4. So just reiterating that, we obtain the two values by considering the coordinate that we're given, and then by using the fact that the asymptotes are related by the expression that we found by considering what happens as x is large. So in terms of marks, obtaining a as 2 will give us 2 marks for correctly verifying and working our way through that, and then for doing the correct verification similarly for obtaining the b value will give us another 2 marks. Okay, so that's part A of the question done. Well, there's a lot more to this question. Now this next part then says the point P has coordinate 1, 0, as you can see shown on the graph. and we have a straight line that passes through P with a gradient of m, and we've got to show that this line intersects the hyperbola if this particular quadratic that is given, okay, this one here, is being satisfied. Okay, so again, for it to intersect we need to solve effectively our two equations simultaneously. So we know the equation of the curve, remember, is x squared over a squared, remembering where a is 2, so that becomes 4, minus y squared over b squared, and of course b squared is going to become 16 if b is 4, and that is equal to 0. Now the equation of our straight line passing through P, if you remember, one way of finding the equation of the straight line, if you know a single coordinate on it and you know its gradient, is to do y minus y1 equals mx minus x1. So in this case y1 is 0 and x1 is 1, so this will just become y equals m x minus 1. So that form, general form of a straight line, if you're given the gradient and a point, is particularly helpful. So to find this equation that has to be satisfied, we need to substitute y equals mx minus 1 into our equation of the hyperbola and then simplify it. So if we do that, what are we going to get? We're going to get x squared over 4 minus m squared x minus 1 squared over 16 equals 1. We multiply through by 16 and expand these brackets at the same time. We'll get 4x squared minus m squared, and then we square this bracket, we get x squared minus 2x plus 1 in brackets, and then the 16 that we get on this side we can subtract 16 over to this side, and so if we now collect the terms together we're going to get 4 minus m squared times x squared and then we get plus 2m squared times x, and then we've got a minus 16 and a minus m squared, so that gives us a minus 16 plus m squared. And then just to finish that off, we can see that that equation is nearly the same as what they were asking us to show. The only difference is our answer is negative compared with theirs, because they got a plus, and that's a minus, that's a minus, that's a plus, and here we've got 4 minus m squared and they've got m squared minus 4. So we just need to write down one more line to get to their answer. So how do we get the 4 marks there? Well, for knowing or managing to find the equation of this straight line would give us 1 mark as a statement. Then eliminating the y's by getting this statement in our first line would give us an appropriate method mark at this point. And then for removing the fractions and eliminating it down to some sort of expression that we could then simplify would give us a mark. And then finally for writing out the one line that I haven't written out, that would give me my 4th mark in here. Okay, so that's part B of the question complete. So part C, we got to show this equation has equal roots for a particular condition. Now, so in part C, we have a quadratic from part B. We know that for equal roots, b squared minus 4ac has to equal 0. So in our particular case, b is 2m squared, lots of x, so it's the 2m squared is the b part. So if we square that, we get 4 lots of m to the power of 4 minus 4 times a, well the a is the m squared minus 4, and that has to be multiplied by the value of c, which is the m squared plus 16. So notice we can do this part of the question even if you could not do part B of the question. Always look out for the fact that when they give you an answer to a particular part of the question, if you can't do that part, chances are you can do the next part because it will follow on from the correct part that they've given you. So now we need to simplify this by multiplying this out. So we got 4, well we can divide through by 4 and get rid of all of these 4's to make life somewhat easier. That would help. So then when we multiply out this bracket, we've got m squared times m squared with a negative, so that's minus m to the 4 with a plus m to the 4, so that's going to disappear. We're going to get a minus 4m squared from this piece with this piece, and there's a negative, so that's just going to give us 4m squared. Then I've got a 16 times that m squared with a negative sign there, so that's minus 16m squared. And then I've got a 16 times that 4, which is going to give me a plus 64. 64, 4 times 16 is 64. Yeah. And it's again a negative times a negative, so that's positive. Yeah. And so that is going to equal 0. And then, what can we do now? We can divide through by 4. Well, we're going to get minus 12, aren't we? So if we rearrange this, we're going to get 12m squared equals 64. So we can divide through by 4 to give us 3m squared equals 16. And so m squared, or 3m squared equals, oh that's the piece we want, isn't it? Sorry, I'm there now, aren't I? Yep, looking back up at the part C of the question is always helpful. Yep, so we're at the point where we need to be. Okay, so again, putting it equal to 0, the discriminant b squared minus 4ac, that's your method mark for 1. Then coming down with something that's appropriate to be simplified will give us 1 method mark for getting partly simplified, and then ending up with the final correct solution will give you the 3rd mark. Okay, so that's part C completed. Okay. So part D then says there are 2 tangents to the hyperbola. Well, the tangents just touch the curve, so that is where we have a point of intersection for equal roots. So that's what we've been doing in parts B and C. So the fact from part C that we know that 3m squared is equal to 16, that is telling us that m squared is equal to 16 over 3. So we can substitute that into the quadratic equation to give us a quadratic that's appropriate. So if we substitute it in, we've got 16 over 3 minus 4, which of course is 12 over 3, which gives us 4/3 of x squared, minus 2m squared lots of x. Well, m squared is 16 over 3, so that becomes 32 over 3x, plus 16 over 3 plus 16. Well, 16 is 48 over 3, multiplied by 3, plus the 16, so that gives us 64 over 3 equals 0. If we now multiply by 3, divide by 4, that gives us the equation x squared minus 8x plus 16 equals 0. And so if we solve this equation, we can see that this will factorise into x minus 4 all squared equals 0. So that tells us that x must equal 4. Well, to get our y value, we then need to find an appropriate method. So it would seem to make sense to use the equation of the hyperbola, since we know x squared over 4 minus y squared over 16 equals 1. We can substitute in the value of x into that, and that will give us 16 over 4 minus y squared over 16 equals 1. Well, 16 over 4 is 4. So if we take the y squared over 16 to the other side and the 1 back the other way, that will tell us that y squared over 16 equals 3. So then we can multiply by 16 to get y squared equals 16 times 3. And then if we square root that, we will get square root of 16 is 4, square root of root 3 is root 3, and then of course because you've square rooted it, that value can either be positive or either be negative to give us our two possible intersections of our tangents that we require. And so we could just finish off by writing down that our 2 points of intersection are 4 root 3 and 4 minus 4 root 3. Okay, so we'll form 5 marks for that last part. So what have we got? Well, we'll get a method mark for substituting the m squared into the quadratic at this point, and then additional method marks for simplifying this down and for obtaining x equals 4 will give us an answer mark. We're using an appropriate method then for finding the y value. In my case I use the equation of the hyperbola, and then for then stating the 2 correct points that you require will give you the final or 5th mark to complete your answer to part D. Well, hopefully you found that solution helpful. For additional help with your further maths revision, please go to the Further Maths Support Programme website.